Hello and welcome to this version 8 release training for the ForecastBuilder software. For this version, there are a couple of big items that are coming with it. The first here is the integration of the graphical hazardous weather outlook grid creation. Another item, the support for Python 2 and Python 3, since Python 3 will be included within the 20.31 AWIPS release. Additionally, there's some bug fixes listed here. But going down further, we have that switch to the NBM PPI-01 and PPI-06, and I'll discuss that here in a little bit. And then also providing some default configuration for Eastern region after discussions with several Eastern region personnel. So let's talk about the PPI-01 and PPI-06 and some of the background. So a lot of this is just a review from the version 7.3 training. But I want to reiterate this again because, again, we're making the full switch here now with this release of ForecastBuilder. So some background here. First about the pop grid. The value of the pop grid is used for 12-hour precipitation verification and to create the words that we have in the weather grid. But as you know, we often like to get a little more temporal resolution to the pop grid, especially in the shorter time range here, like in the today or tonight period, for example. So we want to have, we'll use the pop grid to put more specificity on when precipitation may be a little more likely. And so the pop grid is really a better definition for it will be Precipitation Potential Index, or PPI. And if you go on some of our hourly weather graph, not hourly weather graph pages, but some of the graphical forecast pages, you'll actually see Precipitation Potential Index listed there. And there's even the definition there to show that, it's for forecaster confidence as to the location of precipitation each hour across the forecast area. And, if I were just to reiterate it again here, the PPI, what we have is it excels at conveying the entire 12-hour period chance of precip, and then again showing the most likely timing of it. But the big key here to remember is that the PPI has no statistical basis, an hour-to-hour chance of precipitation. So taking a look at this image from Fort Worth as an example, this grid here does not represent the statistical true 1 hour pop. For that time period of 13 to 14Z. It's just showing that over the northeast section of the grid is where precipitation is most likely. In the NBM, they at one point did try to do a PPI, but with version NBM 3.2, they switched that over to a true 1 hour pop because there were some issues with that PPI. And I tell you what, the true 1 hour pops, they're really useful for specific hour-to-hour forecasts. They're calibrated to that, and they do show precipitation time in detail really well. However, because it's a true statistical 1 hour pop, it's sometimes, or maybe even often, much lower than the 12-hour pop. And here's a nice diagram to show that to you here. If you look at the kind of lighter green, that's your 1 hour pop, and then the darker green is the 12-hour. And you'll see in this situation, I believe this might be just a general air mass convection scenario, that the 1 hour pop is almost half of what, the max of the 1 hour pop is almost half of that of what the 12-hour pop is. And so, if you were just to use the max of the true 1 hour pops to make a 12-hour pop, you are going to result in a tri-bias. And your weather grid categories are going to be completely off. So, since we affiliate a 50% chance with chance verbiage, 90% will just be definite. There's a big change here. In fact, in some, air mass convection scenarios, the true 1 hour pop may only be 10% or less, and then you would just end up with no weather. To make this switch to use the true 1 hour pop would require probably several changes throughout the GFE software and the dissemination. But it's good information, to pass on to customers. Notice too with this, we've been discussing the 1 hour pop, but the 6 hour pop applies as well. Note that the 6 hour pop in this example is 10 to 15% lower than that of the 12-hour pop. if you're looking at maximum of the 6 hours. So in the National Smart Inits, we actually have an algorithm in place that helps convert the MBM, true statistical pops, to a PPI. So we do that by finding the ratio of the max values between the 12-hour pop and the 1-hour pop. And we're essentially just going to scale or stretch those 1-hour pops to that value of the ratio. And you can see this example here where that 50% max now gets lifted up all the way to 90%. And what's really nice too about this approach is that we maintain temporal integrity throughout the change here. And again, ForecastBuilder here can use the MBM PPI-01 for short-term pops and PPI-06 for the long-term pop initialization. And again, the configuration adjustment is now baselined with this version 8 release. And in the configuration documentation, you'll actually see what that setting really is. So looking ahead with the ForecastBuilder development, we do have some tropical integration expected with version 9. The kind of idea behind this is to add a tropical mode into the open GUI there of ForecastBuilder, and it will just essentially call out to various tropical procedures that are available already in GFE. It's not going to be like replacing any. It's just to get the workflow process embedded into the ForecastBuilder flow. Expecting this for early summer for sites that want to test it out. And that's all I have for today's training. Again, if you have any questions or feedback, feel free to reach out via the ForecastBuilder NWS chat room. We have the VLab site as well as the email address listed there. Thank you for watching.